Hello everyone, myself P.Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. So in today's video session, I am going to discuss about the problems on transient analysis of series RC circuit. Okay. So in this series RC circuit, we have to calculate the total current response and voltage across the resistor and voltage across the capacitor. Okay. So here we need to discuss about we need to solve the problems on the transient analysis of series RC circuit by using the differentiation method. Okay. So here I am taking the one circuit here, the circuit consisting of voltage that is 20 volts and resistance is 10 ohm and capacitor is 0.1 farad. Okay. So it is a completely one series circuit, means it is having only one single loop. Okay. So supply voltage is 20 volt and resistance is 10 ohm and capacitor is 0.1 farad. Okay. So now for this resistor, the voltage equation of the resistor is VR is equal to I into R. So what is R value here? 10. So means 10 into I. The voltage drop across the resistor VR equal to 10 into I, and similarly the voltage equation of the capacitor, that is VC, is equal to 1 by C integral of I dt is the equation. Okay. So that is equal to, what is C here? 0.1. So 1 divided by 0.1 integral of I dt. So by using these two equations, we need to calculate the total current response of the given RC circuit, right? So for that, we need to apply the KVL in a given single loop. We need to apply the KVL in a given single loop. So here, apply KVL here. So when we are applying the KVL, we'll get the equation like this. So in this circuit, I am starting from this point. When I am starting from this point, always we need to take the second polarity, means plus 20. So before that, here 10 ohms is there. So voltage drop across the 10 ohm is VR, voltage drop across the capacitor is VC. But current is constant in series circuit. Okay. So plus 20 minus VR minus VC equal to 0. Now 20 equal to VR plus VC. Now already we know the voltage drop across the resistor and voltage drop across the capacitor. So VR is equal to 10 into I and VC equal to 1 by 0.1 into integral of I into dt. Now these two equations substitute here. So we'll get, so 20 equal to VR 10 into I plus VC 1 by 0.1 integral of I into dt. Now, so this equation we have to differentiate on both sides. So here differentiate on both sides. That means d by dt, that is with respect to time. So d by dt of 20 equal to 10 into di divided by dt plus d by dt of 1 by 0.1 integral of I into dt. So now d by dt of 20, so it is 0 equal to 10 into di divided by dt plus, here differentiation and integral get cancelled. Now we'll get 1 divided by 0.1 into I. Right? So we are getting the equation like this: 0 equal to 10 into di by dt plus 1 by 0.1 into I. Right? So now this equation I am writing like this: 10 into di divided by dt plus, so 1 by 0.1 means 10 only, 10I equal to 0. Now take 10 as a common term here. So 10 into di by dt plus I equal to 0. Now 10 will goes this side. So 10 into 0 means 0. So we'll get the equation di by dt plus I equal to 0. Now this equation is like this: di by dt plus pi is equal to q. Now compare these two equations. Now we have to compare first equation and the second equation. So in that, p equal to 1 and q equal to 0. So p equal to 1 and q equal to 0. Right? Now by using this equation, we need to calculate the total current response. That is, I equal to IC plus IP. The total current response of given RC circuit, I equal to IC plus IP, where IC equal to, so already we know the equation, C into e power minus P dt, that equal to constant C into e to the power of minus P. What is P value here? 1. So 1 into dt, that is equal to C into e to the power of minus t. So integral of 1 into dt is t only. So that is e power minus t is IC, that is complementary value, complementary function IC equal to C into e to the power of minus t. Now we need to calculate the particular integral, that is IP, where IP equal to, so here also we are having the equation e power minus p dt into integral of q into e to the power of p dt into dt, that is equal to e power minus p value. What is p value? 1. So 1 into dt into integral q, q value is 0, into e to the power of p dt into dt. So here 0 is there. So entire term will be 0, where IP is equal to 0. Now the total current response, I equal to IC plus IP, where IC, so what is IC value? IC equal to C into e to the power of minus t. So C into e power minus t plus IP value is 0, or the total current I equal to C into e to the power of minus t. Now for this equation, we need to calculate the C, that is constant value. Okay. So for this RC circuit, the capacitor is act as a short circuit here. So here voltage plus minus and resistance is there. So here voltage is 20 volts and resistor is 10 ohm, and it is short circuited. Now by using this circuit, we need to calculate the constant term, that is C, or I, total current I equal to, according to Ohm's law, V by R, that equal to, what is V? 20 by R, 10, that is equal to 2. Now substitute this C value in this equation. So we'll get I equal to 2 into e power minus t. The total current response of the given circuit is I equal to e to the power of minus t is the equation. Now we need to calculate the voltage drop across the resistor. That is, at resistor R, VR is equal to I into R. So that equal to, what is I value here? 2 into e power minus t into, what about the resistor value? 10. That is equal to 20 into e power minus t is VR value. So this is voltage drop across the resistor, and this is the current unit is amperes. And similarly, the voltage drop across the capacitor, Vc equal to 1 by C integral of I into dt. That equal to, what is C here? 1 by 0.1 integral of I, 2 into e power minus t into dt. That is equal to 1 divided by, so 0.1 I am writing like this, that is 1 divided by 10 into 2 is constant. So 2 into integral of e power minus t into dt. That equal to 10 into 2 integral e power minus t dt. That is equal to 20 into e to the power of minus t dt. Now integral of e power minus t dt is 20 into e power minus t divided by minus 1, or Vc equal to minus 20 into e to the power of minus t volts is the voltage drop across the capacitor. Okay. So for this RC circuit, the total current response is I equal to 2 into e power minus t, and voltage drop across the resistor is VR equal to 20 into e power minus t, and voltage drop across the capacitor is Vc equal to minus 20 into e to the power of minus t. Okay. So this is about the problem on series RC circuit with differential equation. Okay. So thank you one and all.